Good evening, everyone. Good evening. Here we are, Wednesday evening. Just checking that that's the right angle. It's not like my face is going to change much, but it is what it is. But I just like that angle. Soon I will start making some lights somewhere to make it cooler, to make it more like professional, to make it more like a professional. How would you call someone who actually works? Well, works. Does tweets like generally speaking, like more than just once. Hello everyone. I can see we have like a streamer. Yeah, more professional streamer. That would probably be the best definition. Is the sound okay? Is the video okay? Everyone happy? All good? I don't know who was yesterday. Someone told me that it was lagging, and I was like, really? I have a second camera in here. Sorry, a second screen. And it seems all right. Okay, thank you. I see that we have already 10 people in here. Wonderful. My plan today is not going over exam questions. Some of you probably you will be happy that I will not show you some exam questions, but we will go through topics that they are in the exam. The only thing is just I will not just show you one exam question here and go through it. It's because I noticed that some people felt like they were not included. And this is about science. It's about include as many people as possible. I think that one positive thing about science is that it's universal. It's for all over the world. We do science. We talk about science. We work about science. Yeah, I told him exactly the same thing. That he's just his wife. He just needs to move to the living room. Before we start, let me show you one mug that one colleague in the school gave to me. Look, the bullying I need to suffer every day in school. Mr. Lazy. Nothing true than that. Alright. Okay, so the topic I have chosen for today, as you see, is to talk about the atom, the chemistry of the atom. Okay? And I love this topic because from here we can take so many things and we can talk about so many different topics. Alright? And also connects chemistry with physics, and it allows me to talk about one of my favorite topics, which is about the periodic table. I love the periodic table. When I was a student in high school, my teacher forced all of us to learn the periodic table by heart, and I found that extremely useful. It was Miss Cooper. I will expose her in here. It was Miss Cooper, the one who bullied me, okay? So make sure that tomorrow or next day when you see her, you tell her about Mr. Lazy. Say you betray me, you cancel judo. Okay, I will explain what happened with judo in another time. Now we're going to talk about the atom, alright? I thought I changed the name of the stream. Could you please reload, process start, could you please reload the page, because for me it's saying chemistry of the atom. Guys, could you please tell me if it is saying chemistry of the atom or it is chemistry of the atom? Wonderful. All right, so let's start. So, as you know very well, everything that is a material is made of atoms. And when I mean everything that is a material, I'm talking about the table, this paper, you. We are all made of atoms, and all the material things that are made of atoms. But now some of you might be thinking, wait a second, sir. In our last lesson, you mentioned that the basic unit of living things is cells. Yes, cells are also made of atom. An atom is much smaller than a cell. A cell is the smallest living thing. Meanwhile, the atom is everything that is a material is made of atoms, and atoms are not living things, okay? Please don't confuse atoms with cells. I put some music, some jazz in here, banging. Oh, it's a bit loud. I want it as a background. Gentleman music. This is gentleman music, okay? So, as you know very well, the atoms, they are made of subatomic particles, okay? Meaning that an atom is made of even smaller particles of the atoms. Okay? Yes, I can make pools now. Before I could not make pools because I didn't have enough subscribers, but now I can make pools. So, the atom, you know, it is made of protons, neutrons, and electrons. This is something that some of you might know, some of you might not know. So I am just recapping, okay? So, important, these two, they are found in the nucleus. Meanwhile, the electrons, they are orbiting around the nucleus, okay? Wait a second, this music is distracting me. And it's something without lyrics. Better. I don't know about the ads. I don't know about the ads, why there are ads. That's not me. That is Twitch making money with this stream, okay? Anyway, so why this is relevant? Because you know that the periodic table has approximately 200 elements. Elements, they are just one type of atom. And it's an atom with a specific amount of protons, neutrons, and electrons, okay? If you could have your periodic table next to you during... that's a bit for that's for another topic, process stars. We can do energy calculation in a different topic. If you could have your periodic table with you, banging. If you cannot, you would need to trust me, okay? The periodic table looks like something like this, okay? Like this, okay? It has 18 groups and 7 periods, okay? Remember that periods is up to down and groups are the other way around. It has 18 columns and 7 periods. This is a period, 1, 2, 3, 4, 5. So every one is a period, and groups is each column. Okay, each column is a group. Group 1, group 2, group 3, group 4, group 5, group 6, group 7. Okay, and period is 7. Sorry, 8. Sorry. So it has 18 groups, and one group is one column. Group 1, group 2. Group 3, but you know that the middle one, you need to ignore it. Ignore it. They are called transition methods and they are not part of your exam. So it goes 1, 2, 3, 4, 5, 6, 7, 8. 8 being periodic table, or the periodic table, the noble gases. Sometimes they also call it group 0. So it has 18 groups, but for you 8, and it has 7 periods, okay? And periods is from left to right, 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 left to right. Okay? But now, what is the meaning of those elements? Each element has a particular combination of protons, neutrons, and electrons. And you can see that represented, for example, this element, which is an element that all of you should know. What element is this one? One person already answered. Let's wait for more answers. Only one person knows the name of this element. Well done, David. Want a pool? Okay, let's make a pool just to make you happy. Name the element. And I give you 3 answers. Silicium. There you go. Bomb. There you go, the pool. There you go, the pool. Let's see the results in 3, 2, 1. It is obviously lithium. Well done, guys. Obviously lithium, okay? The majority of the elements, their name will be similar to their name in English. However, that is not always the case, all right? We could have a false friend like this one. What is this element that has... What is this element now? Meh. No. Nope. Yes. It's not gold. It's not gold. It's not gold. Guys, it's not gold. I know you want some gold, but it's not gold. No, it's not iron. It is silver. Okay? And the reason is very simple, guys. There are more languages than English. Okay? There are more languages than English. So, for example, lithium, yes, it's like the name in English. But Ag, silver, comes from the Latin argentum. Okay? It's a Latin name. And from Argentum comes the name of the country Argentina. Why? Because Argentina is full of silver. Argentum, Argentina. Alright? Connection. Latin language, always important. Anyway, what are these numbers that we have in here? They're super important because they tell us what I was mentioning earlier, the combination of protons and neutrons in the atom. This one is called the mass number, and this one is called the atomic number. It's quite common among students saying that mass number is the one on the top, atomic number is the one at the bottom. But that will lead you to a shameful mistake. Sometimes this one can be on the top, this one at the bottom, but I have seen other periodic tables where it's the other way around. So you cannot just learn it top, bottom, okay? You cannot be the bottom of the group, you need to be the top of the group. So how do we distinguish which one is the atomic number and which one is the mass, the atomic number and the mass number? There is a trick. There is a Mr. Romero's trick. The mass number is always larger than the atomic number. Always. Always, always, always. Okay? Always the mass number. So if instead of this periodic table, they give you a periodic table that is like this, you still know which one is the atomic mass, the mass number, and which one is the atomic number. Okay? It doesn't matter what sort of periodic table they give to you, you will be able to identify which one is each. Well done, Process Stars, you know it very good. Alright? Let's talk about what is the meaning of the number, because those are not just random numbers. If you have noticed, the periodic table is ordered according to the atomic number. What do I mean with this? The first one in the periodic table, group 1, period 1, is hydrogen. After hydrogen, you have group 1, and then in here is helium. Then you have lithium. In here you have beryllium. Here you have boron. Here you have carbon, nitrogen, oxygen, fluorine, and I think the next one is neon. Okay? And this one is 3, 4, 5, 6, 7, 8, 9, 10. If you look at the atomic number, it goes from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a B, okay? It looks like a D, but it's a B. There is no element that has D, okay? I know the majority of the periodic table by heart, but this is not a show off, okay? It's about telling you the periodic table is in order of the atomic number, not the atomic mass, atomic number, okay? And what it's telling us is information about how many protons, neutrons, and electrons we find in each atom, okay? Because depends on that, we're gonna place them in the periodic table. Imagine that the periodic table is like a bookshelf. And the bookshelf is in order according to the amount of, in this case, protons, because the number of protons is the most important. So, I will choose another example that is not lithium because I'm getting tired of lithium. By the way, lithium is used in batteries. So all the batteries nowadays, they are made of lithium. And when they enter in contact with water, when lithium enter in contact with water, they explode. I don't know if you have seen videos of Tesla cars exploding. That is because water enters in contact with lithium batteries. It can be from the rain or it can be from anywhere. When water and lithium comes together, that is a very exothermic reaction, okay? So it's not obviously good for a car because if it is inside a car, they explode, okay? Yes, this is chemistry. We are talking about chemistry. We are talking about chemistry. Chemistry of the atom is the first topic. And the second topic is periodic table. We are talking about the periodic table. Hello, wake up. Let's talk about carbon. Carbon has 6 and 12. By the way, you are made of carbon. You are also made of carbon. The one who is asking me if this is chemistry. So, no worries. You are more than welcome. Everyone is more than welcome here. Love and compassion. We love you. We love all of you. So, the mass number. Mass number. And here we have atomic number. As I mentioned earlier, the most important one is the atomic number. The atomic number is like the ID. It's like the ID of the element. It is impossible two different elements with the same atomic number. That is completely impossible. And you should be able to identify. You should be able to identify. You need to how to say? Reload the page. Okay. It should change the name. The atomic number is like the ID. Think that is some sort of the ID of the element. It is impossible two elements with the same atomic number. It's impossible. And only with the atomic number you should be able to identify the element. And it tells you the amount of protons in the nucleus. And it's super important. Exclamation mark, super important. Alright? Extremely important. What about the mass number? The mass number tell us, let me use the color. The mass number tell us amount of protons plus neutrons in the nucleus. And that's why the mass number is always larger than the atomic number. So for example, in the case of carbon, which is the one we are talking about here, we have an element that has 6 protons and it also has 6 neutrons. How do I know that this element, this atom, has 6 protons and 6 neutrons? Because 6 plus 6 gives me 12. Okay? It's no magic. It's that easy. Alright? What do you think? Easy, difficult, super easy, super difficult? What do you think? Give me some feedback. Do you find this easy, difficult? Come on, show me you are in here. Easy peasy. Of course it's easy peasy. 50-50. Okay. I will give you another element, alright? Do you want a heavy element or you prefer a light element? Let's give you a light one, okay? In this chat, we are all very fit and we like to do exercise, so let's give you a light element. Okay, this one. Oxygen, 16, 8. Okay, Super important oxygen, the one that keeps us alive, the one that we use to make hydrogen is too easy, come on. Don't be crying, babies. Hydrogen is too small. It's the smallest one. Oxygen is fine. So tell me the amount of protons and neutrons in the atom of oxygen. Come on. Chop chop. I will give you a minute. In the meantime, I will read your comments. Okay. Eight protons, 8 neutrons, 8 electrons. Yes. What add? What area are you talking about? There is no atom in here. You cannot see me? You cannot see me? Can you see me? I didn't know this has ads. I'm concerned now. Alright, so the answer is 8 protons and 8 neutrons. And I know this is happening because the total number needs to be 16. You're taking an ad break. No, didn't touch anything. How long is it saying? Anyway, so it has 8 protons and 8 neutrons. But David earlier said that it also has 8 electrons. The thing is, you know that it has 8 electrons because I told you that it is an atom. But this is not always the case. This is not always the case. How do we call an atom that has lost or gained electrons? For example, imagine we have an oxygen atom that instead of 8 electrons, it has 10 electrons. First of all, how do we represent this? How would we represent an oxygen with 2 more electrons? And then how would we call it? Exactly. It will be an ion and it will be oxygen 2 minus. Oxygen 2 minus. And it will be called an ion. What is the definition of an ion? Is an atom that has lost or gained electrons. So my point is, the number of electrons can change. You can have an an atom that has lost or gained electrons. That's completely normal. That is happening all the time. Thanks to this movement of electrons, we have electricity, and you can see me and I can talk with you. Electricity is the movement of electrons, all right? However, what is not that easy to change is the number of protons and the number of neutrons. That requires a much more difficult process. But electrons, they are moving around all the time. They are very light, they are very little, they are very easy to move. You can literally move electrons by just getting a balloon and wrap it over your head. That is gonna make electrons to move. Electrons are moving all the time. So it's very common to have ions, okay? It's super common. The other important concept that you need to remember is the concept of isotope. Isotope, which is something that my year 11 you should be very, very familiar with at this point, but probably if you are in younger years, you haven't seen it yet. What is an isotope? Okay, I mentioned earlier carbon. Carbon, which is the material, the atom we are made of, normally is carbon 12 and carbon 6. But those who are into history or you are into archaeology, you might have heard about carbon-14 test, which is also carbon. So what is the difference between carbon-12 and carbon-14? Well, the difference is not the amount of protons. Both of them, they have 6 protons. Meanwhile, but carbon-12 has 6 neutrons. That's why 6 plus 6 makes 12, the atomic mass. But in here, carbon-14 has 8 neutrons. That's why it is an isotope. They are atoms of the same element, but they differ. I move the camera. They differ in the amount of neutrons. And you might be thinking, sir, and how this is relevant, how this is important? Well, this is super important. First of all, this one, carbon-12, is the element you are made of. Carbon-14 is radioactive. And we cannot be made of. Or for example, another one, this element with an U is uranium. And you can find in the nature, outside there, you can find 2 uraniums. Uranium-238 and uranium-235. This one, you can have it on your hand, like the pen, and you will still be fine. This one, we use it to make nuclear bombs. So some isotopes, they are more dangerous than others. Do you understand? That's why it's important to learn about isotopes. So, we have been learning about today the atom, subatomic particles. We have talked about atomic mass and atomic number, how the periodic table is arranged. We have talked about ions. We have talked about isotopes. Please, David, make some clips about this. I need to go now because I need to go to judo. I'm coaching there today and I need to arrive on time. My next stream is gonna be tomorrow. It's gonna be for A-level physics, and then the next one is gonna be for you on Friday, where I'm gonna keep talking about chemistry. It's gonna be a weekend focused into chemistry because your older brothers, they have their exam on Monday. We wish them their very best, and we're gonna do our very best effort to help them as much as possible. Okie dokie, guys. Yeah, sure. One day maybe you can play to us. In the meantime, if you have any question, any problems, please don't hesitate to write me whenever you want, guys. Have a lovely evening. God bless you all. Bye bye.